Hello everyone. So this is a question from JEE Mains 2026 8th April Shift 2. X is the product which is obtained from benzene by reacting it with carbon monoxide and hydrogen chloride in the presence of cuprous chloride. Y is the major product obtained from benzene by reacting it with ethanol chloride in the presence of anhydrous AlCl3. The product major obtained by heating X and Y in the presence of alkali is Z. Okay. Total number of pi electrons in Z is okay. So the chapters involved is hydrocarbons, aldehydes, ketones, and carboxylic acids. Okay. So whenever a mixture of carbon monoxide, CO, and HCl gas is passed through a solution of benzene, okay, and the temperature is around 323 Kelvin. In the presence of catalyst, whenever we have catalyst CuCl, cuprous chloride, so benzaldehyde is formed as the product. Okay, so with respect to reactions, I can show it in this fashion. So we have benzene, and the reactants are CO and HCl, and the catalyst that we are using is cuprous chloride, that is CuCl. So we will get benzaldehyde. Okay, so this guy is our X. Okay, and also this reaction is known as Gattermann-Koch reaction. Okay, cool. So next is benzene react with acid chlorides. Okay, benzene will react with acid chlorides, and acid chlorides have the general formula RC double bond O Cl. Okay, and benzene react with acid chlorides in the presence of anhydrous AlCl3 to form aromatic ketones. Very important. So I will write that down. Benzene react with these guys. They are known as acid chlorides in presence of anhydrous AlCl3 to form aromatic ketones. Okay, and this reaction is very famously known as Friedel-Crafts acylation. Okay, so in our case, the acid chloride, that is this guy, given is ethanol chloride. Okay, the acid chloride given to us is ethanol chloride, and it is also known as acetyl chloride, and its structure is CH3 C double bond O Cl. Okay, so therefore with respect to reactions, we can write that benzene is reacting with CH3 C double bond O Cl. So this is our benzene, and this is our ethanol chloride or acetyl chloride in the presence of anhydrous AlCl3 and heat. So we will get an aromatic ketone, okay, which will look something like this. Basically, one hydrogen in any benzene position is replaced by a CH3CO group. Okay, so we will get a benzene ring and with a CO or a CH3CO group, okay, or a acyl group. So these groups are in general known as acyl groups. So this guy is known as acetophenone, and obviously we will have HCl as one of the side product. Okay, and this acetophenone is nothing but our Y. Okay, and in the third part of the question, they are saying that when X and Y is heated in presence of alkali, okay, X is benzaldehyde and Y is our acetophenone. Okay, so whenever they are heated in presence of alkali, let's say we have dilute NaOH. Obviously, you can see one of them is a aldehyde, the other one is a ketone. Okay, so obviously whenever you are heating them in presence of dilute NaOH, they undergo crossed aldol condensation. So the reaction will be crossed aldol condensation. Okay, and if you look at the structure of both of them, that is benzaldehyde is this guy, acetophenone is this guy. Okay, so acetophenone contains alpha hydrogens. These are the alpha hydrogens, right? Alpha carbon is the carbon next to the functional group. Okay, so acetophenone containing alpha hydrogens will attack the, so these hydrogens are going to attack the carbonyl carbon of benzaldehyde, because benzaldehyde does not have any alpha hydrogen. You can see this is the alpha carbon and it has no hydrogen attached to it. Okay, so therefore these alpha hydrogens are going to attack this carbonyl carbon to give us the aldol. Okay, so with respect to reactions, I can show it in this fashion. So I will draw them again, showing charges now. So oxygen will take these electron pairs, therefore it will have a negative charge, and this carbonyl carbon will have a positive charge. Okay, and I will write acetophenone in this fashion: CH2. I will separate the alpha hydrogen, C double bond O, and benzene ring. Okay, alpha hydrogens can be lost, therefore there is a positive charge here, and therefore this carbon will have a partial negative charge. Okay, so obviously this hydrogen will be extracted by this oxygen, and this carbon with a, it will take away these electron pairs, and these lone pairs will attack this carbon which bears a partial positive charge. So therefore we will eventually get our aldol. Our aldol will look like this. So we will have the benzene ring carbon, it will have OH, NH, and this carbon would have formed a new bond with this CH2. So we'll have CH2, C double bond O, and a benzene ring. Okay, so this is the aldol. Okay, so this initially formed aldol will undergo dehydration. That is, it will lose a water molecule to form an alpha beta unsaturated carbonyl compound. Important. Initially formed aldol will undergo dehydration to form an alpha beta unsaturated carbonyl compound. Okay, so you will understand the meaning of this once you see the final product. So obviously drawing the aldol again, so we'll have the benzene ring, COH and H, so separating the hydrogens to show the loss of molecule of water, C double bond O, and this is our benzene ring. Okay, so this is the aldol that we get. OH from here and H from here goes out in the form of a water molecule, and therefore the final product that we are going to get will be benzene ring, CH. There will be a double bond here because OH out, H out, so there will be a double bond here. So we will have CH, double bond CH, C double bond O, and a benzene ring. Okay, and obviously a molecule of water. And this guy is known as benzyl acetophenone. Okay, so now you can understand why is this alpha beta unsaturated, because this is the functional group alpha carbon beta carbon, so there is a double bond between alpha and beta, so therefore alpha beta unsaturated, and carbonyl because you can see there is a C double bond O group. Okay, cool. And the driving force for this dehydration, that why is there a loss of molecule of water, is conjugation of the double bond, that is this double bond with the benzene ring and the carbonyl group. So can you see double, single, double, single, double? Because of this conjugation, it makes this particular product extremely stable. So this guy quickly loses a molecule of water to become ultimately this guy. Okay, so therefore this is our Z. This is our Z. Okay, and in the question they are asking us how many pi electrons are there in Z. So you can see how many pi bonds are there? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 pi bonds. So therefore, the number of pi electrons will be 8 into 2, 16 pi electrons. So therefore, 16 will be the correct answer. Okay. Thank you.